Over 30 years, construction and design costs only make up 2% of the total cost of building ownership. The other 98% includes the cost of utilities, maintenance, and personnel. In this video, we will be talking about one of the ways architects help decrease these expenses through performance modeling. I'm Jesse Bowman, an associate principal here at Newman Munson Architects. Throughout the design process, your architect should find ways to improve performance and reduce these long-term expenses. One of the most efficient tools at an architect's disposal is performance modeling, the process of running a design through software to simulate building performance. Today, we will talk about how architects can use performance modeling throughout the architectural process, how it impacts the design decisions, and its importance. Performance modeling begins with shoebox models, where architects test building shapes or massing in modeling software. This analysis helps determine the best way to position the building for optimal sunlight, solar orientation, and identify the most efficient proportions. The goal is to minimize the surface area volume, SAV, the amount of surface area needed for the building's volume. By reducing SAV, you lower construction and maintenance costs, and performance modeling helps an architect find the most efficient shape within your project constraints. Performance modeling also helps determine the best window-to-wall ratio, WWR, the percentage of windows compared to the walls. While windows are essential for natural light and comfort, they can also cause energy loss. So the goal is to balance daylighting with energy efficiency. As WWR increases, energy loss rises, often requiring larger mechanical systems. To optimize efficiency, your architect may adjust the window placement or interior layouts. They'll also consider site factors like wind patterns. For example, reducing windows on the northwest side can improve efficiency during cold Midwestern winters. By balancing solar orientation, SAV, and WWR early in design, your architect can enhance both occupant comfort and energy efficiency. In addition to factors like solar orientation, SAV, and WWR, the mechanical system plays a major role in energy efficiency and operating cost. Early modeling helps your architect estimate system size, and as the design progresses, they can test different options. Mechanical systems, including VAV rooftop units, boiler/chiller setups, VRF systems, and heat pumps. Each has its own initial and lifecycle cost. Your architect should perform a lifecycle cost analysis to help you balance upfront expense with long-term utility and maintenance savings. The goal is to find systems that fit your budget and minimize future costs. As the design process moves forward, your architect can use performance modeling to fine-tune decisions for maximum efficiency. Modeling can inform choices like glass type, insulation levels, HVAC zones, door selections, and power controls, each impacting performance. For instance, higher performing window glazing can lead to significant energy savings. A payback period measures how long it takes for these savings to cover the initial cost. Glazing, just above code, has a 17-year payback, while better glazings reduce that time to 9 years. Performance modeling is most effective when the building receives a third-party inspection from a commissioning agent. Commissioning agents review construction documents and construction work to ensure the building operates as intended. Learn more by reading about commissioning and its benefits.